The fundamental theorem of calculus is, as the name suggests, probably the most important theorem in all of calculus. And it connects two things that we often use interchangeably but are actually two quite different things. Over here I've drawn the graph of y equals x squared and indicated the area underneath the curve between 0 and 3. The way that I would represent that is by writing the integral from 0 to 3 of x squared dx. What that means is the area over here. We're talking about this area. In order to solve this algebraically, we know what to do. We do the antiderivative, and we write that as 1/3 x cubed from 0 to 3. We plug in 3, we plug in 0, we subtract them. But the question is, why does that work? Why is doing the algebraic opposite method of finding a derivative, why would that somehow give you the area underneath the curve? There's no obvious reason why the reverse algebraic process of finding the slope would somehow give you the area underneath the curve. The fundamental theorem of calculus proves that those two, unbelievably enough, coincidentally enough, that those two things that seem like they should have nothing to do with each other, area under a curve and the opposite algebraic process of finding the derivative, end up actually being the same thing. You wouldn't think that they would be the same thing, but they actually are. And that's why, based on that, is why we can say that the integral, you can get the integral or the area under the curve by finding the antiderivative. This next worksheet that you're going to do is all about doing that proof, proving that the area under the curve can be found by doing the algebraic reverse process of finding a derivative.